Fourth grade into math lesson 13.2, explore angles. I can compare angles and use unit angles to find how many of the unit angles complete a circle. Spark your learning. The Jayhawks designed a flag with no angles that are the same size. Ospreys design a flag in which two angles are the same size. Draw and describe the flag for the Ospreys. Okay, so what are our key things here? There are no angles that are the same size, right? Okay, so our picture can't have any angles the same size. Could we draw a right angle on one?
Yeah.
Possibly, right? Okay. Then could we do, what else could we do?
We could do like a side angle.
Could we do it more open?
Yeah.
Yep. And then if I did this, what kind of angles are those? Acute, right? Because they are less than what? 90 degrees. Okay. Build understanding number 1. Competitors in an obstacle race must overcome 3 ramps. An angle is formed when 2 rays are connected at a common endpoint or vertex. The black outlines show the angles that make up each ramp. So connect to vocabulary. A vertex is the point where 2 rays of an angle meet. Okay, so it's this point right in here, and then the vertex is formed coming off of that. So how can you compare the angles? So how can we compare them?
They both have like an alligator mouth.
Well, okay, so they kind of have the alligator mouth, but are they less than 90 degrees, more than 90 degrees? They're all less than 90 degrees, right? Okay, so what are they? Are they right, acute, or obtuse? Acute, right? Okay, so anything less than 90 degrees is acute. A right angle is how many degrees? 90, and then an obtuse is anything more than 90 degrees. So how can you order the angles from least to greatest? So you can tell by the way they, how more closed they are or more open they are, which one is the least, right? So which one is the least?
The orange.
Oh, sorry, they want greatest to least. So which one's the greatest? The purple. Okay, and how do we know that? Is it more open? Yeah, the arrows right here are open a little bit more, right? Then which is the next color? Green, because they're not quite as open, and then the orange. Oh, there we go. Number 2, the posts for swing obstacles make an angle outlined in blue. How can you make a unit angle to measure the opening of the blue angle? Okay, so what could we do? Could we make like a little piece of paper, and could it be smaller than what that shows?
Yeah.
Yep. And then could we find that?
Yeah.
Yeah. Okay. Okay, so we could take a piece of paper, trace it, right? Okay, and then find that angle. All right. So then how would we figure out what the angle of the blue is? So if we had that little piece of paper, could we take that and then add that however many times to get it? Okay. Okay, so our little angle that we made 3. It took 3 angles to fill up the blue part. Okay, so you can also use a protractor. We're just using abstract dimensions right now, okay? And eventually you will use a protractor to help you figure out the exact angles, okay? Number 3, a wagon wheel is in the shape of a circle. It has wooden spokes that connect directly from the hub to the rim, forming an angle. How many of these unit angles come together in the center of the circle? How can you use the unit angle to find the number of angles that make up the circle? Okay, so they have that there's one set, right? Okay, they want to know how many it would go all the way around. So what could we do? We just use like a little piece of paper on the other side. Could we now form a wedge and see what that is and then put it around that many times to see how many spaces it fills up? Okay. Okay, so we stuck our little paper in there and we found that we could come around here and we would get, there's 2, 3, and 4 got us halfway around. So how many total angles would it take to go all the way around the whole circle, guys? 8, because we had 4 for half and 4 for the Check understanding number 1. Kenneth draws angles to make a design for a team's jersey. Circle the angles that appear to be the same size. Okay, so which one's considered the same size?
The first and
The first and the third, okay? Because we can tell that the middle one's a little bit bigger or smaller? Bigger or greater, okay? Number 2, compare the angles, then use the angle colors to write the angles in order from least to greatest. So which one is the smallest angle? Which one is not open very far? The blue. Okay. Then which one is next?
red.
Is that red? Okay. All right. Red. How do we know? It's either a right angle or maybe just a little bit more. It's either a right angle or a little bit more than a right angle, correct? Okay, so that gets us about 90 degrees. And then the green is what? It's more than 90, so it's an obtuse, and it's quite a bit more than 90, right? Number 3, using the unit angle shown, how many unit angles come together in the center of the circle? So once again, we're going to take our little piece of paper, we're going to trace what the outline for that one section is, and then see how many times it fits around the circle as a whole. Okay, so after using our little piece of paper and going around, we found what? How many times? 6 unit angles. Now, how come I can't just put 6 angles?
Because there's just regular angles.
Well, are they all the same size?
No.
Yes, they were all the same size. So therefore, are they the same unit? Yes, so that is why we have to put 6 unit angles. On your own, number 4, Austin makes a poster to display the rules of an obstacle course race. The poster will be in a shape that has 2 pairs of angles that are the same size. Draw what the poster might look like. How do you know the angle pairs are the same size? So to get us 2 angles that are the same size, would 2 90-degree angles be easy? Okay, so we can only have 2, right? Okay, so there's 90 degrees. Then what else can we do? So we could do kind of obtuse. Could we do like a house? Yeah. And then would this side over here be the same? Yeah. Right? Okay. So basically these right here were 90-degree angles, correct? These right here were obtuse angles, so those 2 pairs were the same. And then is that one at the top the same as the other? No. Okay, so you have right angles here, obtuse angles here, and then at the top, what type of angle would that be? An acute. Okay, because it'd be less than 90. Number 5, compare the angles. Then use the angle colors to write the angles in order from greatest to least. So this time they went the biggest to the smallest. Okay, so which one would be the greatest? What color? The green, because it's a what type of angle? Obtuse. What would be next? The red, because it's probably close to an what? A right angle. It's probably acute the way it's looking, but it's probably pretty close to a right angle. Okay, and then which one's next? Blue, because it's an absolute acute angle, right? Using the unit angles shown below, how many unit angles come together in the center of the circle? So you're going to use your little piece of paper and you're going to trace that corner and then see or that angle and see how many times it completely fills up the circle. Okay, so after using a little piece of paper, we found that we can get 9 unit angles of that size to fit around the whole entire circle. So number 7, make a unit angle to measure the green angle. What is the measure of the green angle? Okay, so on this one, you guys could stick your paper in there and you could all have different answers, right? Because you could have, if you picked a smaller angle, then it's going to clearly take more of those to fit in that space, right? If you picked a bigger angle, it's only going to take maybe a couple of them to fit in there, all right? But what for sure type of angle is this? An acute angle.